Okay, assalamualaikum and good morning, everyone. So, how's your test? I hope it's 50-50 ke, tak adalah teruk sangat, okay? And the quiz is not made by me, so jangan bagi markah impact saya rendah tiba. Okay, so for the quiz, actually I'm still waiting for the answer from the lecturer who made this quiz. So for question 1A, we will skip first, okay? Because to be honest, I'm not sure how to answer this, and we go to question 1B and probably question 2. So question 1B is about block diagram reduction. So later in final, there will be another question on block diagram reduction. So let's discuss on this question, okay? So if you still, let's discuss on this question, okay? So if you still remember block diagram reduction, you have 6 rules, okay, to follow. Basically, the general rules that if you follow, inshallah, you can solve the block diagram. So the first rule is you reduce the cascade first, and then followed by parallel. Then third one is feedback. So if you don't have, if you cannot find any of these three, then you need to start with moving the pick-off point. Pick-off point to the right. And moving the summing junction to the left. Then lastly, you repeat the process. Okay. So if you look at this question, there's a feedback between 1 over s and minus 6 here. So you can feedback them first. After you feedback, then you cannot remove this summing junction because there is minus 8 here that goes to this summing junction. Or you can move pick-off point. So the pick-off point that you can move is this point here. You can move to this side, to the right, okay? So if you move this pick-off point, then it seems like you need to have, it seems that you need to do modification to two blocks, this one and also this one. So the best way to do is to take feedback first and then move the pick-off point. Okay, so let's try. So the first step is feedback. Okay, so you feedback these two, 1 over s and minus 6. Then you get this form, okay? So let's simplify that. So you get 1 over s minus 6, okay? And then after that, you can repeat the process. So you can move this pick off point to the right. Okay, so if you move the pick off point first, then you need to consider um, multiplying with for to these two box, okay, minus 6 and 1. But since you feedback first, then if you move this pick off point, then um, you only need to consider only this box on top here, the box 1 here. Okay, so the second step is moving pick off point. So 1 divided by 1 over s, so you get s. So s here. Okay, so from here, then you can see that these two are cascade. And these two are parallel. And then these are feedback. Okay, so let's simplify. So we have cascade. So cascade at this point here. And then we have parallel. And lastly, feedback here. So let's simplify. Ini feedback tadi. Okay, so you can simplify the feedback. So you will get s squared minus 6s plus 8 plus ini. Okay, and then from here, you can see that these two are cascade. And since the box 2 here goes to the same summing junction with the cascade one, the cascade box on top, so both of them are parallel. Okay, so we can simplify this straight away. Cascade ys over us equals, so cascade 2s over s squared plus 6s plus 8 plus 2 represent the parallel, and this one cascade. This is cascade and parallel. So further simplify, you get okay. Ni lah kot jawapan dia. So if you have a question on block diagram reduction, try to follow the rules given, because the rules given here, although it's taken from internet, but the rules given here are trying to solve the plot diagram to get the easiest, I mean the simplifiers, is it correct, the most simplified final transfer function. Okay, you can follow a different steps, but what will happen later, you will find out that the transfer function obtained, the final transfer function obtained will be maybe a bit complicated. Okay, so the steps given to produce the most simplified transfer function. Okay, so try to learn more on block diagram reduction. Okay, try to do the exercise or example given in the slide. Okay, so let's go to question 2. So question 2, a mechanical system is shown in figure 3 which subjected to a massless frame displacement with respect to the force acting on it. The base of the mechanical system attached is stationary floor. The parameters that involved in the system are, so from the system, derive the equation of motion in terms of Laplace transform by assuming that the initial conditions are 0 and determine the transfer function of the system if the output are the massless frame displacement. Massless frame displacement. So y1 lah kot. So soalan A dia nak y1. Okay, dia nak y1, dia tak cakap y1 over apa, so kita assume dia y1 over f. Okay, basically cari y1 sebab y1 tu lah massless frame. Tapi kenapa dia tak label? Mungkin dia saja nak bagi korang tu kot, saja nak bagi korang pening. Okay, so let's try this. So we look at the Maybe we can start with massless frame first, okay? So massless frame. Okay, so massless frame. So dia tak ada mass, so tak payahlah lukis ni. So massless frame. So the massless frame is connected with a spring K1 and K1 here. So two spring K1. So since Y1 is acting upward, so the force by spring K1 will be downward. So K1, Y1, 2, okay? 2KY, 2K1, Y1. And then there is a spring K2 here connected to the massless frame and spring K4. So K2, Y1, K4, Y1. And then there is a friction between M2 and the massless frame. So you have FV2, Y1 dot. And your force F is acting downward. F. Okay, now let's look at the forces acting upward, which are the components that are also connected with other masses, okay? So here K2. Oh yeah, kita forgot FV3 here. So FV3 Y1. Okay, so the other components are K2, K4, and FV3, FV2. So K2, Y2, K4, Y3, FV2, Y2 dot, and FV3, Y3 dot. Bapak banyak gila. Okay, so this is the first free body diagram. Okay, let's do the second free body diagram. Y2. Okay, so on Y2, we have K2, K3, FV1, FV2. So K2, Y2, K3, Y2, FV1, Y2 dot, FV2, Y2 dot. And then K2 is connected to massless frame. So K2, Y1. Okay, so M2 ada moment of inertia. Ada inertia dia, so M2, Y2, double dot. Okay, so K2, Y1, and then K3, Y3, and FV1, Y3 dot, and then FV2, Y1 dot. Banyak gila. Okay, so block diagram number 3. So here you have K3Y3, FV1Y3 dot, K4Y3, FV3Y3 dot, and M3Y3 double dot. And then K3 is connected to Y2, FV1, Y2 dot, K4, Y1, FV3, Y1 dot. Berapa markah ni? 15. And then arrange in, you can write the equation of motion. So sebab dia nak equation of motion. So write the equation of motion. In terms of Laplace transform. So FV2 plus FV3S plus minus minus F. So this is the first equation. And then second one, second equation. And lastly, Okay, and then you can substitute with the value given. Patutnya substitute dari awal pun tak apa. Okay, substitute lah kita. So you get 2s plus 4 and then determine the trans function of the system if the output are the massless frame displacement. Apa panjang gila. Lecturer pun tercedok nak jawab. So susun dalam matrix.
Jelas sangat lah.
Macam mana? Sorry tak dengar.
Tulisan tu macam tak jelas sangat.
Okay, jap. Tebalkan sikit. Sorry. Okay, and then determine the displacement of massless frame. So massless frame y1. So y1 s equals okay, and then boleh simplify kan. Nak simplify ni buat sendiri lah. Okay, if you have your answer in y1 in terms of determinant, I think you should get marks for this. If you simplify, maybe dapat dalam 1 atau 2 markah lagi. Okay. And then the next question is, the displacement of the massless frame show the great amplitude value. In order to overcome this matter, an additional damping element have been attached to both sides of massless frame. Evaluate the impact of damping element by determining the transfunction of the system if the output still the massless frame displacement. So mengikut kefahaman saya untuk soalan ni, we add another damper here and another damper here. So there are 2 dampers added. And then you need to modify your equation to add the effect of damper. So when you add damper here, connecting the massless frame and the platform, so you only modify the first term here. You only modify this, and it will not affect the other masses. Okay, it will not affect the other things like this y2 and y3. So it will affect on this only. So adding 2 dampers, meaning that you will add 2s. Okay, so your equation now change from 2s here becomes 4s plus 4. So maybe boleh buat some justification, okay? Or you can say that adding FV4 on both sides meaning adding y equals to s on y1, ataupun nak redraw block diagram balik pun boleh. So modify first equation of motion. So you get 4s plus 2 plus 4. And then cari balik y1. So y1 equals okay, and then function, okay, and then the impact of damping element Apa dia nak? So let's try simplify kan. Okay, so kalau when you simplify the trans function, if you look at the top, the numerator, there's no changes in terms of numerator. Okay, it will stay the same because um, the position of 4s plus 4 is here, and 2s plus 2 is plus 4 is here, meaning that when you simplify the determinant, the numerator determinant, it doesn't affect the numerator, but it will affect the denominator, because numerator, the denominator, you have 4s 2s plus 4 here, but on the second question you have 4s plus 4 instead. So the effect, I think, you add another poles to the system. Okay, if you simplify this, you will get some equation, let's say d. Okay, but here you have another d, but you are adding this term here for s plus 4, meaning that there is another pole. So maybe if you add another pole, if the poles, if you calculate the poles and the poles are on the left hand side of the s plane, then the system is stable. If the poles are located on the right hand side of the s plane, then the system might be the system is unstable. So the impact, if my answer, the impact is you are adding another pole or additional pole, or you adjust the poles of the system. The impact of adding dampers So when you modify the denominator, then it affects the stability, because we know that from previous two lectures, we need to use the denominator to determine the stability, maybe by using Hurwitz or by finding the poles. Okay, so when you add damper, then it affects the stability, but of course you need to calculate the stability. Okay, but this is how I will answer the question. Okay, so that's all for midterm test. So question 1A, I will discuss with you later, okay? Okay, so let's look at your quiz. Number 9. So question 1. Determine the stability of trans function below. Okay. So first we do the route Hurwitz table. So we start with S5, then followed by S4, and then we arrange the coefficient alternatingly. So 1, 2, 2, 4, 11, 10. And calculate for S3. So you get 0 here. So when you get 0, then you know that you need to use the first case of route Hurwitz, which is when there is a 0 in the first column. Okay, so we check whether you have 0 in another column. Okay, so you don't have 0. So we straight away use method number 1. Okay, so I prefer to use the reverse coefficient method. So you get new TS equals 10s power 5 plus 11s4 4s cubed plus 2s squared. Okay, you reverse the coefficient and then restart the Hurwitz table. Okay, so there is no more 0 in the first column. Then you can continue as usual. Okay, you get some value here. Let's say A. You get 0 here. Okay, A yang ni lah, okay, kira sendiri lah, okay. And then from the first column, check for sign changes. So if you have any sign changes, meaning that your system is unstable. Okay, so for the first method, what you need to do is you need to check first, meaning that you need to do this step first. Check whether there is a 0 in the first column. If there is a 0 in the first column, then only you reverse the coefficient. So most student usually skip the first part here and straightway reverse the coefficient. So you lose maybe 2 marks, okay? 2 marks above here. So in this question, if you show the first step here, you get 1 mark. 3 marks, 2 marks, 1 marks for reversing the coefficient. 2 marks for the new Raut-Hurwitz table, and 1 mark for determining the stability. Okay, I will send to you the form, Google form later, okay? Okay, so let's look at the second question. So determine the stability of the system below. So first, you need to simplify the block diagram. Okay, so Raut-Hurwitz criteria. For Raut-Hurwitz criteria, when you want to use Raut-Hurwitz, you need to first simplify the block diagram. Then you can use the Raut-Hurwitz criteria. So let's simplify the block diagram. So CS over RS equals okay, and then we take the denominator. And then we do the Raut-Hurwitz table. So we start with S power of 8, followed by S power of 7, and then arrange the coefficient alternatingly. So you get 1, 3, 10, 24, 48, 96, 128, 192, 128, and 0. And then S cube, S6. Oh, so ada calculator. So you get 2, And then S5. Belum apa-apa dah tahu dah unstable. Serious, salah kira. So ni dapat semua 0 sebenarnya. Okay, and then when you get 0, then you need to modify S6. So we take the equation PS equals and then differentiate. And then substitute this new polynomial into S5. So S4, okay, and so on. Okay, kira sendiri lah. Boleh tercedok jawab soalan macam ni. Okay, tak keluar soalan macam ni. Okay, kalau keluar pun bukan SEM ni. Okay, so if you simplify the block diagram, then you get 1 mark. If you do the differentiation here, you get 2 marks. Graph width table, 1 mark, and 1 mark for determine the stability. Okay. So that's for quiz 9. So for take home quiz, take home quiz ni okay, so for take home quiz, basically the question asks you to describe how to use Hurwitz table. So when you try to describe, tak payah detail sangat, do not be so detailed, but just like making a short notes, okay? Macam buat toyol, macam nak buat toyol, macam tu lah korang discuss. So for question A, maybe you can start by saying, use the denominator. So So ds equals s4 plus 2s cube plus 3s square. And then start RH table with S4 and S3. And arrange coefficient alternatingly. So macam mana?
5 tu benda-benda dapat 1000 ke?
Sebab sistem ni dia tak cakap pun dia unity feedback ke ataupun anything, okay? Lagipun dia dah bagi tahu sini the stability of an open loop system, meaning that the system is already open loop. Open loop maksudnya GS kat sini. So sini RS, sini CS. So dia tak ada feedback. So bila tak ada feedback, meaning that the system is already simplified lah. Unless kalau dekat sini cakap unity feedback. So unity feedback rasanya saya boleh explain. So kalau unity feedback, then dia ada -1 kat sini. Tapi sistem ni dia open loop. Open loop meaning that dia tak ada feedback. So straight away guna GS je, tak payah tambah 1000. Tapi kalau tambah 1000 pun tak tahulah dapat stable ke tak. Tapi kalau katakan you dah terbuat tambah 1000, rasanya ada je markah. Because this question kita nak tengok macam mana you explain Raut-Hurwitz je. Macam mana nak guna Raut-Hurwitz table. Okay, so from this table, then you say for stability, check for sign changes. In first column. Okay, so from the TF, there are two sign changes. So this system is unstable. So markah dia dapat dekat sini. Guna denominator. And then arrange alternatingly. And then 1 mark for the table. 1 mark for saying check sign changes in the first column. And then 1 more mark by giving example sistem ni stable ke unstable. So if you use untuk soalan tadi, if you use plus 1000, it's still okay, but make sure you show macam mana nak explain, make sure you explain macam mana nak guna Raut-Hurwitz table ni, Raut-Hurwitz criteria. So the calculation here, kalau salah pun tak apa sebenarnya. Katakan you salah kira kat tengah-tengah ke, kat mana-mana ke, tak menjadi masalah. Yang penting you explain, kita tengok dekat first column ada sign changes ke tak, dapat markah macam tu. Okay, so for the second question, there are cases when there is a zero in the first column while forming the Rath-Hurwitz table. Describe how do you modify the Rath-Hurwitz table that has one of the cases above. Okay, so dia bagi transfer function baru. Okay, so the first step you need to do is to check whether there is a zero in the first column. So start with S5, S4. So tak payah explain balik. Arrange alternatingly, use denominator because yang ni dah explain dekat soalan A. So kalau lah kita nak ajar dekat adik kita ke Rath-Hurwitz criteria, cakap dengan dia soalan A kan dah ajar tadi. So benda sama je. Tapi sekarang ni nak kira ada zero ke tak? Okay, so tak payah tulis balik benda yang sama. So here, arrange alternatingly. Okay, so you get 0 here. 3 tolak 10, 7. Okay. From the TF, from the Rath-Hurwitz table, there is a 0 in first column, row S3. So if you have this, dekat sini ada markah 1. Then there are two methods. You can use the epsilon method or reverse coefficient. So kita guna yang senang lah, reverse coefficient. So reverse the coefficient. Of the DS. So ni satu markah. And then we reverse the coefficient. So new DS. Okay, satu markah lagi. Then do RH table as usual. Okay, so kira macam biasa. Okay, so if you have this table, berapa markah dah? 3, macam tak cukup je. So ni 2 markah. And then look at first column. So there are 2 sign changes. So unstable. So 5 markah. So ni jadi 2 lah, 2 markah, 2 markah, 2 markah. 4 markah kat sini. 2 markah sini. 2 markah kat sini. Okay, yang penting kena cakap reverse coefficient. Reversekan coefficient and then do the rock width table. Okay, last question. There are also cases when there are zeros in an entire row while forming the rock width table. Describe how do you modify the rock width table. Okay, so take the denominator. And then as usual, okay, so ada entire row of 0. Then cerita sikit. Row S3 has 0 entirely, okay. So use row above to form polynomial PS. So satu markah sini, satu sini, satu sini, and then PS equals S4 minus 3S squared minus 4. Okay, satu markah lagi. And then differentiate PS with respect to S. So dps ds, you get 4s cubed minus 6s. Okay, satu markah lagi. Then use dps ds to replace row S3. Okay, so start dekat S4, 1 minus 3 minus 4. Then S3, 4 minus 6, 0. And then maybe boleh cakap continue as usual. Okay, so S2, you get minus 6 plus 12 minus 3 minus 4. S1, minus 16 minus 18 0. S0, minus 4. Okay, so berapa markah tadi? 3, 7. So ni 2 markah. And then look at first column. So one sign change here from here to here. So one sign change. So unstable. Okay, so one mark here. Okay, so untuk question 3, yang penting ialah kena beritahu ada zero in entire row, and then use the row above to form a polynomial, then differentiate the polynomial, and then replace the new polynomial into S3 for the row with all zeros, and then continue as usual. Okay, so that's all for uh, today's lecture. So this week I want you to submit the market paper, okay? And your score, and also submit your report part 2 and part A by end of this week. So Wednesday tak ada kelas, cancel. So we will start new lecture next week, Monday. So Rabu ni cancel sebab ada aktiviti lecturer. So dia suruh sama ada cancel ataupun ganti. So kalau let's say if we don't have enough time to cover all lectures, then we will replace a class, okay, this class on Wednesday. But hopefully we have enough time to finish all lectures, okay. So if you have any question, you can ask me through WhatsApp, okay. And so that's all for today's class. Assalamualaikum. Bye.
Thank
Thank you.
Thank you, sir.
Thanks.